My name is Andy Davis. I'm Research Director at NCC Group, and this afternoon I'm going to be talking to you about some of the research I've done into laptop docking stations and, more appropriately, what interesting things you can insert into docking stations as an attacker. So just a quick slide about NCC Group. We've got offices around the world, security consultancy, very research driven, and I'll get straight onto it and won't talk too much about the corporate stuff. Okay, so what are we talking about this afternoon? First of all, why docking stations? Why did I choose that as an attack platform within a corporate environment? We'll talk a bit more about how they actually work, or how they're supposed to work in their default configuration. If you were to put an implant within a docking station, what would you want it to do? And how would you control it? You need a control platform at the center of that, so that as a remote attacker you can get it to do things that are useful to you. Obviously, if you're going to insert something inside a docking station, you need to understand how to best use the physical space available within there. We'll then go on to talk about how, as a defender, you would detect that somebody had inserted something malicious within docking stations in your organisation, and talk about different strategies that you could employ to mitigate those attacks, and then wrap up with a conclusion around the technology and future research. So first of all, why did I decide to take a look at docking stations as an attack platform? Well, if you think about it, they sit in quite a powerful position within an environment, within a corporate environment, within an organisation. They've got access to all the ports that are available on a laptop that's connected to it, internally to them, and quite often they provision additional interfaces that aren't actually available on the laptop itself. They're also used in hot desking environments, predominantly, and therefore, as opposed to having some kind of implant within a specific laptop, having an implant in the dock means that potentially you've got access to a range of different laptops, maybe a different one each day if you've got quite a large hot desking team and lots of different people that are moving throughout the office. The dock's permanently connected to a power supply, and normally to the network as well. So you've got a permanent power supply to supply any kind of implant that you've got that would then perpetually be running. They're generally considered dumb devices. They're trusted by users, and they're trusted by IT admins. They're relatively low-cost items within an IT estate, and as a result of them being low-cost, they're not particularly well physically protected. They're passive and anonymous, so you could easily replace them within an environment, and people wouldn't notice that they'd been replaced by something that looked identical. And there's often plenty of space inside the case for additional hardware. One really key point that I'm going to come back to later on in this talk is the fact that you could have the most sophisticated, high-grade cryptographic algorithm protecting data as it traverses your network. But once it reaches an endpoint, like a laptop, and is decrypted, at the dock, you've got the opportunity to intercept that data once it's been decrypted as it's supposed to be. So, for example, analog audio. You might have analog audio transmitted across the network, highly encrypted, and once it gets to analog audio at the end, when it's at the laptop, when somebody plugs in an audio jack to listen to it, if you can tap the analog audio at that point rather than trying to intercept it off the network, it doesn't matter how high grade the cryptographic techniques or algorithms are that protect it in transit. So is the threat realistic? Well, yes, I believe it is. If you look at some of the kind of hardware-based attacks that have been used over recent years, I'm sure you'll all have seen hardware-based keyloggers that typically inserted in line between a keyboard and a PC. They've been linked with various high-profile fraud cases or hacking attempts, and moving on from these kind of very, very simple devices, if you were a very motivated attacker with the skills to modify electronic devices, it's the next logical step to take if you want to take a hardware-based approach to attack either specific individuals or a range of individuals within an office in an organisation. So, how do docking stations work? I'm going to be focusing on a specific laptop docking station from Dell, the Dell ePort Plus. And I'm not picking on Dell docking stations for any reason other than the fact that it's the one that I use at work. And it just happens to have a reasonable amount of internal space that's available for putting additional hardware in there. And for this particular bit of research, the prime concern really is how much space you've got for the additional electronics. They all pretty much do a similar thing. Some have got additional functionality, but in this particular case, the Dell ePort Plus extends all the interfaces on the laptop. It provisions a number of new interfaces, so it gives you additional USB ports. There's an internal USB hub. And on your laptop, you've only got a single display port, so it provisions an additional one of those and a couple of DVI ports. So the majority of the electronic circuitry inside, which we'll go into in more depth in a minute, is all about provisioning these extra interfaces. There's a passive Ethernet switch in there, so when your laptop is plugged onto the dock, the Ethernet port on your laptop is disconnected and it's kind of routed through to the laptop dock. So it's not like there's a NIC built into the laptop dock, it just routes it through to the different UTP socket on the back. Now, there's no publicly no publicly available information about the design of this. And no public details about the E-series dock connector, which is the long connector on the bottom of the laptop that interfaces with the dock. So what we need to do is we need to take it apart and have a look and find out more information. So this is taken from the manual. I'm not going to go into too much detail here. It's just showing you the fact that there's plenty of ports on the back of there. The connector between the laptop and the dock is just this large proprietary connector here. Really useful feature of this particular dock is in its default configuration, it's extended because it has been designed to allow you to buy an additional high-capacity battery that extends out of the back of the Dell laptops. So they've designed it so that if you have one of those large batteries, you move this little slider here and it pulls this bit in and it shrinks the size of that. But the default configuration is in this expanded state, which basically doubles the internal capacity, and it's just air in there, so plenty of space for putting interesting things. Very easy to take apart. Just a few photos there showing the deconstruction process. There's nothing clever about the way that you take it apart. No gotchas in there. And I then went through and had a look at all the different chips that were on the circuit board. and did some searching around for data sheets to find out as much information as possible about what it was doing. As I said, the majority of the circuitry in here is to provision the additional ports that are on the back, and also to boost the power of the signals associated with some of the interfaces to ensure that in the distance between the dock connector on the bottom of the laptop and the additional interface on the back of the dock, none of the signals degrades, so you don't lose any quality with any of the interface technologies that are used. Controlling it all, you have this I/O controller specifically designed for port replicators and docking stations, but it's literally designed just to control each of these extra chips that are provisioning the extra interfaces and boosting signals. So nothing particularly clever, and as I said at the beginning, it is predominantly a dumb device. So what would we want a hardware implant to actually do? Well, there's a whole range of different interfaces on the laptop and potential access to all kinds of different information. So we want to be able to capture interfaces, capture data from interfaces of our choice, potentially insert some data. If we were controlling the laptop and we had access and the ability to inject data, maybe keyboard events, mouse events, that kind of thing, then that might be something that you want to do. Once you've captured the data, you're going to want to exfiltrate that in some way via some out-of-band channel. And depending on the type of data that you've captured, you're probably going to want to do some kind of front-end filtering on that. Because your out-of-band channel is going to be significantly lower bandwidth probably than the data that you're capturing. Certainly if you're capturing network data, that kind of thing. It will be useful to identify when different laptops are connected. So, for example, if you're capturing over a long period of time, you want to be able to differentiate between different users. If a laptop's disconnected at the end of the day and then reconnected the next day, you want to identify whether it's the same laptop or somebody else. And of course remain as stealthy as possible throughout. You don't want somebody to identify that there is something strange going on with their laptop dock. So the first and most obvious thing that you might want to capture is network data. It's not the kind of panacea of network data capture, because a lot of protocols these days are encrypted. So if you're purely capturing the data off the network itself, the only benefit is if it's going to be unencrypted data or unencrypted authentication credentials. But if you're going to do it, passive network tapping is definitely the most stealthy way of doing it. And in the example system that I developed, I used a circuit that was designed by Michael Osman, which if any of you have ever designed a passive network sniffer, you've probably used this design or something very similar to it. So it's completely passive in that it's non-powered and will support 10 base T and 100 base TX. Unfortunately, it won't support gigabit Ethernet, because with gigabit Ethernet, data travels in both directions simultaneously on the wires for which 10 and 100, they travel unidirectionally, so it kind of doesn't work with the circuit. But a nice, clever technique to get around this is the fact that if you've got a gigabit Ethernet network, you can insert capacitors. I'll show these two capacitors here, and they perform a kind of hardware-based downgrade attack against Ethernet. So when you plug in your Ethernet cable and the switch that it's connected to is trying to work out what speed to use, those capacitors filter out the frequencies that are used for gigabit Ethernet, and it will downgrade to 100 base TX. So that makes it slightly less stealthy, but you've got to be a pretty switched on administrator to see that that's happening on your network. On the Dell dock, having a look in more depth, we've got a module here produced by the Amphenol Corporation in Taiwan. Managed to track down their data sheet, which shows the pins that you need to tap for the Ethernet. So you've got Ethernet pins there, and it's part of this module. It's also got USB ports in there. So it's basically these ones in green in the middle are the pins that are associated with the Ethernet port. So those are what you need to tap. So this is just a couple of photos of the fact that you can tap just directly off the bottom of the circuit board. And encircled there are those two capacitors that are used for the hardware downgrade attack, just in case it's gigabit Ethernet. And those two UTP connectors there will then connect into my control platform that I'll talk about a bit later. So if you're not quite so concerned about stealth, you might want to go for an active network attack. The obvious problem of the passive network attack is if you want to do something useful, so maybe you want to start launching some network-based attacks or do some kind of penetration testing via the device that's installed within the dock, you can't do that with a passive attack. So you need to move on to a slightly more sophisticated approach. Clearly you're going to need more space because you're going to need some kind of Ethernet hub to allow you to perform a network attack, active network attack. And there's more engineering involved to get that inserted inside, because that's going to need to be inserted kind of in line between the laptop and the dock within the circuit board. And of course it's more likely to be detected because a new device is going to appear on the LAN when that's active. Another interface that you might want to intercept is video. So you can use a number of different techniques to do this, but there's a product on the market called Video Ghost, which some of you may have used. And what this product allows you to do is periodically grab screenshots of whatever's being displayed on the monitor at the time. So it's very stealthy. It's not. It doesn't. There's no way that I'm aware of detecting its presence. And if you look at this diagram here, you've got a USB connector which provides the power when it's in this kind of standard configuration, and that red dongle on the end acts as a mass storage device to store all the different images that are taken as screenshots. And you then connect the one with the green circle into the VGA socket, and then the white circle connects into the socket within the dock. So it would have to be wired in actually onto the circuit within the docking station, but would effectively allow you to do frame grabbing of all the video that was going through the laptop docking station. And again, all the pins to the VGA socket are clearly available on the bottom. And at first glance, excuse me, at first glance, this seems pretty straightforward. However, when you actually look at how the VGA port has been physically implemented on the board, it's part of a module that contains the parallel printer port, which is at the top, that big pink chunk, and also a serial port. So all of that is one big module. And this is the VGA port that we want to get to, and it's kind of enclosed by a cage of parallel port pins. So if you were going to insert a tap in there, you would have to remove that module and physically replace it with separate items, which, if you're a dedicated attacker, is not really an issue at all. But not something that I was prepared to go through and do. But it would literally be a case of replacing the individual items, and instead of having a PCB mount VGA, you'd have inline pins on there, which would then connect through to your video ghost. Maybe you want to intercept a USB keyboard or PS2 keyboard, both of which interfaces are available on that particular dock. And as I mentioned earlier, the hardware keyloggers have been around for many years and are easily available. Sometimes I've heard anecdotal evidence of people in high security environments deciding to use PS2 rather than USB still, and completely disabling USB as a result of the USB vulnerabilities that you see these days. It would be easier to tap PS2 keyboards using the conventional kind of inline hardware keylogger approach, because with the kind of inline USB tap approach, you would need to know prior knowledge of which particular port the keyboard is going to be plugged into. However, there is a different approach of sniffing USB that we'll come on to in a minute. So there's a dual PS2 module if you're going to intercept that, and again the pins are easily accessible on the bottom of the PCB. So if you knew for a fact that your target was using PS2 for either keyboard or mouse, and that's something that you wanted to tap, that would be very easy to perform. And it may be that you want to do some kind of keystroke insertion. It's been demonstrated in various different implementations that you can emulate a USB HID device using something like an Arduino microcontroller to insert keystrokes, and therefore if the laptop that's connected to the dock is logged in and nobody's looking at it, then you could insert a whole load of keystrokes and get it to do all kinds of things in the context of the current logged in user. However, you need to be pretty sure that there's nobody looking at the screen, because this is going to be highly suspicious if somebody sees the Windows Start menu coming up and run and all kinds of stuff going on. So yeah, not very stealthy at all. PS2 emulation is also possible with a microcontroller if, as I said, the target's using PS2 rather than USB. Audio monitoring. As I mentioned at the beginning, you can have the strongest network encryption in the world protecting your audio stream as it goes across the network, but at some point it needs to be decrypted so the person at the other end can listen to it, and that point is at the laptop. So at the dock, where you've got access to the analog audio jack socket, where they may have some headphones plugged in or a pair of speakers, then you can just tap off the analog audio. So more and more corporates are using VoIP, using soft phones. So there's a good chance that you're going to potentially get access to sensitive audio using this technique. And this is, of course, assuming that you're using the audio mini jack rather than a USB-based audio solution to listen to the audio at the dock. As I said, they're just pure analog audio signals, easily tapped off the bottom of the PCB there. Now this slide's entitled webcam monitoring, but it technically should be USB monitoring. A lot of laptops these days come with webcams installed by default, and they are normally wired directly to the internal USB bus on the laptop. So if you can tap that USB bus, then and you can reverse engineer the encoding mechanism that's used to encode that video stream, then potentially you can intercept any video that's being recorded or processed by that webcam. And this applies to anything else on the internal USB bus. However, when we're tapped on the USB bus within the dock, I mentioned that there's a separate USB controller within there. And this is a downstream USB bus to the one that we want to monitor. So we need to gain access to the upstream bus, which is actually on the laptop itself. So how do we do that? Well, in order to provision this downstream additional USB controller, there is a USB controller chip for which you can download the data sheet for. And you can see that the 2 pins on there that provide access to the upstream USB upstream bus are those 2 pins there, 30 and 31. So rather than tapping the USB actually on one of the ports, which would give you access to any of the devices that were plugged into USB ports on the dock, you tap onto these 2 pins on the actual USB controller to tap the upstream ports, which will give you access to all the USB traffic actually on the USB bus within the laptop itself, which will give you access to anything that's plugged into the ports on the laptop rather than onto the dock. And you can see there on the PCB, it's those 2 pins there. So you need a very small soldering iron tip, but it's certainly possible to do. So I've mentioned about this proprietary dock connector. In days gone by, 2 series ago, 2 series of Dell laptops ago, back in the C series days, they used to publish details of what the pins were for their proprietary docks. And back in the days of the C series dock, there were, I think it's about 200 pins, something like that, slightly more pins than you get on the current dock. And although there's no information about the current 144-pin dock connector, from the previous pin-out, you can see the type of information or type of data that's presented on this proprietary connector, assuming that at least some of this is still present on the newer connector. And what's interesting here is the fact that some of this stuff is not available on any of the other physical interfaces on a laptop, only on this proprietary dock connector. So there's potential for some future research there, and not something that I've looked into in any depth yet, but I think there's scope for some interesting stuff. So the control platform, how are we going to control this implant? It needs to be small enough to fit inside the dock. We need to be able to configure it enough to be able to handle the different interfaces that we're going to intercept and process. It needs to be reasonably powerful, because if we're going to be performing kind of front-end processing on the data prior to exfiltration, it needs to be able to do that. And of course we need to be able to remotely control this via some kind of out-of-band communications channel, so that we can access it without anyone being aware that we're doing so. So the control platform is based on a Raspberry Pi called SpyPi, and so at the center of it you have a Raspberry Pi computer which is running Linux, and then here I've shown the different potential interface taps that you could develop for this. On the example that I've produced, I've only done the passive Ethernet tap so far, but theoretically you could quite easily develop all these other ones here based on the information that I've told you. And the exfiltration path and control path is via a 3G or HSPA modem that's connected via USB, so out to the internet, to the attacker. So I'm sure many of you have played with Raspberry Pi computers. They're pretty small devices based on the ARM11 and run Linux, and perfectly powerful enough to do the things that we need to do. However, slightly limited in the interfaces that are available, so there's some extra bits that we need to buy to connect to it. So by default, the Model B only comes with one Ethernet port, and we need two if we're going to do the passive Ethernet sniffing. So an external USB-based one of those. And also, the Raspberry Pi doesn't come with an analog audio input, so you need some kind of USB-based sound card in order to process that if you're going to be intercepting the analog audio. And as I said, with some of the injection techniques, you might want to use an Arduino to do HID injection. So there's additional little bits of electronics that you might want to interface to this as well, depending on exactly what you want to be tapping. And of course, for the remote connectivity, you need an HSPA or 3G modem. Again, there's a USB solution. And you've got two design choices with your remote connectivity. You need to have a think about whether you want to have the device store everything that it's collecting and then periodically forward it to you as an attacker, so calling home, excuse me, or whether you want remotely initiated full control, so the attacker decides when he wants to connect in and investigate what's been collected so far, or maybe change the configuration, that kind of thing. And your design choice, it all depends on how stealthy you want to be. So for example, the store and forward one, you could actually have the modem turned off during the day, and it only enables and starts forwarding out data maybe at 2 a.m. when you know that there's not going to be anyone in the office. Whereas obviously the remotely initiated approach, the modem needs to be there and able to auto answer at any time. So as you can see, this is the dock with the top cut off. To give you an example of the physical space available inside, if the top was actually on there. This big metal bar along here is a counterbalance for when you press the button to release the laptop. It pushes up these bits here on the other end of the metal bar to force the laptop off the dock connector. So you have to make sure that any electronics that you add in here is clear of that bar, because that bar goes up and down depending on whether there's a laptop connected or not. So as long as you make sure you clear that, which is only about 1 centimetre tall, then you're okay. And as you can see, there's plenty of space in there. Power considerations. I said at the beginning that laptop docks are permanently connected to a power supply, and so power clearly shouldn't be a problem here. The DC voltage provided at the input is 19.5 volts, and we only need plus 5 volts to power all our implant stuff. And I didn't have a schematic or design for the dock. And I could see that there was plus 5 volts at many places across the PCB, but it wasn't clear as to what current limiting was in place at the different points. So decided that the easiest way to do was to tap directly off the DC input and just drop it down to plus 5 volts using a simple voltage divider. So putting it all together, here's the dock. There's the dock as it is standard. There's the dock with the lid removed. And just to show you clearly what it looked like inside when the implant was installed, I fabricated a clear Perspex lid. So you can see that it's closed, and it's so there's plenty of space inside still, but you can see the Raspberry Pi inside and additional electronics. And it's raised up on those little legs so that it clears that big chunky piece of metal that moves up and down. Now, I was planning to do some kind of demo for this, showing me connecting into this and demonstrating capturing some network traffic. But the more I tried to come up with something innovative, the more I realised that basically all you're going to see is a shell of me connecting to a Linux box, and it could be any Linux box. So it's quite difficult to show that what I'm actually connecting to is running within the dock. So I decided not to show the video of me just connecting to a Linux box, because you all know what it looks like connecting to a Linux box. So how do you go about detecting hardware implants? Well, with the passive network tapping example that I gave, if you're using a gigabit Ethernet network, which most people are these days at least, then you would notice that there was a speed downgrade because of those downgrade capacitors that you need to downgrade it to 100 base TX. So theoretically, if you were looking for it, then you would spot that one of your laptop docks on the switch, or looking at the different switch ports on your local switch, you'd see that one of them was running at 100 base TX rather than 1000 base T. But you definitely have to be looking for something like that. With the active network attack, as I said, you would see a new interface appear, so a new MAC address would appear on the network. And with the keystroke insertion, that would definitely be easily visually spotted. You'd have to make sure that there was nobody in the room at all when you were kind of virtually typing on somebody else's machine, especially as it would have to be unlocked, so it would be visible on their screen. So what other techniques could you use? Well, weight is an obvious choice. You could weigh a known good docking station, and then periodically go around and weigh your docking stations to see if any were heavier, assuming that they'd be heavier if they had additional electronics inside. Well, okay, yeah, it's a simple technique in theory. You don't really need any specialist equipment. You just need some weighing scales, but very labour intensive to go around weighing your docking stations. You're going to be a pretty paranoid organisation if you that you need to go around weighing your docking stations. And also, if you're a really motivated attacker, you could offset the weight of your additional electronics by modifying the internal design. That big chunky piece of metal that was used, you could easily reduce the weight significantly of the laptop dock by replacing that with some kind of composite material. What about heat? Well, the infrared heat signature ought to identify the additional electronics that are running inside the dock, especially if you've got lots of different interfaces being tapped. But even if it's just the Raspberry Pi, it should give off a decent heat signature. It's a simple technique. There's plenty of different types of thermal imaging camera available on the market, ranging from reasonably inexpensive ones all the way up to some really good quality, highly sophisticated ones. Again, though, it's pretty labour intensive to go around, get one of your security guards trained up on using a thermal imaging camera and get him to point it at all your laptop docks every night. And theoretically, you could reduce the heat signature using thermal shielding. Fortunately, we managed to get hold of a thermal imaging camera to have a play with it. And if you haven't played with a thermal imaging camera and you ever get the opportunity to, I suggest you do. It's great fun. We had hours of fun with it after we'd spent 5 minutes demonstrating this. So this is a picture of the implant powered off, and there's the implant powered on. And you can quite clearly see the heat signature there reveals that there's additional electronics in there. You may ask, well, why isn't there any heat coming from any of the electronics on the board underneath here? Well, that's because the electronics in the dock don't actually get powered up or the majority of the majority of the electronics on the dock don't get powered up until you actually put a laptop on there. But even so, there's nowhere near as much heat being generated by all that electronics as on our implant there. So it's certainly a viable technique to be used. And I just need to say thanks to Mike Tarbard of ETV, who actually lent us the thermal imaging camera and gave us hours of fun playing with it. So what other techniques could you use? Well, RF emanations. Again, this is a bit of a theoretical one. Yes, if you've got an HSPA 3G modem in there, especially if you've gone for the remotely initiated full control option where it needs to be running all the time, you could detect that there's GSM-based signals emanating from the dock. But in a modern office, there's so many devices that are using that frequency range. You know, people with their mobiles, with their legitimate 3G cards within their laptops, tablet devices. So it's pretty unlikely that you're going to spot, one rogue device within an environment like that. Current consumed. Well, any additional electronics within the laptop dock is definitely going to need to consume some more current, and that's something that you're not going to be able to hide. So as a technique, you definitely need to be able to. You're definitely going to have some current that's in addition to the current that's normally consumed by the dock, and it's relatively easy to measure using a current clamp or some kind of inline device. But again, it's really, really labour intensive. It's not the kind of thing that you want to be able to do, on a daily basis, go around and measure the current consumed by different docks. And it may well be that there's quite a variance between the different docks. I don't know how static the amount of current is that's consumed by these devices. So I think it's pretty impractical, really, as a technique. So what about preventing the implants from working or preventing them from actually being installed in the first place? On the active network connection, you can do port level filtering on your switch. As I mentioned, on the network sniffing side, if all your network traffic's encrypted, then the attacker's not actually going to gain anything by being able to tap that. By far, though, the most impressive kind of techniques for preventing this is physical security-based controls. If you physically secure the docking stations, in addition to physically securing your laptops, then people won't be able to swap them out and swap them in quite so easily. It's interesting when you go around a corporate environment and you see these laptop docks in hot desking environments. You'll see the docks that haven't got laptops connected to them not in any way physically secured, even though they do have the Kensington slot in the side of them. And then the laptops that are connected to them, because they're obviously worth significantly more money, they'll have their Kensington locks connected to them. So for the price of an additional Kensington lock to lock the dock, you're preventing or significantly hindering the opportunity for somebody to swap that out and swap it in with a new one. And also, if you put anti-tamper seals on the bottom, then you would stop someone who had an extended period of time to access one. Say if they broke into the office overnight, it would then make it much more difficult for them to insert an implant while it was in place rather than taking the dock away. Potentially RF shielding. As I said, if you've got an RF modem in there that you're using for your command and control, if you've got some way of shielding that, then you prevent it from being controlled in the first place. So, future research. Well, I mentioned that the dock connector, the proprietary dock connector. I'm really interested to find out what can be achieved from an attacker's perspective by plugging into the dock of a running laptop. So if you've got access to a lot of the buses that aren't accessible by any of the other external interfaces, what potential attacks could you do maybe against the OS that's running on there? So that's something that I'm going to look at in the future. I'm also interested in looking at some of the other docking stations that are available other than the Dell ones, purely to see if there's any extra functionality on those that add to this discussion that I haven't covered in this talk so far. And I intend to speak to some of our clients and find out if any of them have encountered any particular dock incidents. In fact, it'd be interesting to see, is there anybody in the audience who has ever thought someone's tampered with a laptop dock in their organisation? Yeah, I didn't expect to see any hands. It's kind of a niche thing, but as I said, I think it's a viable attack, and it's something that if you were going to do a targeted attack against an organisation, it's quite a stealthy approach to take. But I'd certainly be interested to know if anyone has ever had any concerns that one of their laptop docks has been tampered with in some way. So, conclusions. Laptop docking stations, they're widely used, they're widely trusted, they're thought of as dumb devices, they're really, really low-cost devices that are considered throwaway. But they sit in a very powerful position within any organisation and have extensive access to lots of potentially sensitive information from a number of different users on a daily basis. So in days gone by, people have targeted hardware for attacks. So they've used keyloggers, video loggers, and I really see that docking stations are the next logical step for the type of people that use that approach. As I've shown, there's a number of different ways for detecting these implants. I think probably the most effective way to detect them is using the thermal imaging camera, as you saw. But by far the easiest approach is to prevent any implant being inserted in the first place. So physical security around the dock and anti-tamper stickers on the bottom of the device, around on the base of it, to stop people from being able to open it and insert an implant when it's in situ. Does anyone have any questions? Yep.
Just a quick, I was thinking one other mitigation technique would be to use the same kind of see-through lid as you created yourself.
Yeah, that's a pretty straightforward way of doing it, yeah. And maybe something to recommend to the dock manufacturers if they're concerned about this, yeah. Yep.
I've seen firewire connectors on docks. I guess that would make it easy to attack probably with the DNA attacks.
Yeah. It's not something that's. Is there one available on the PRO2X? There might be one available on the current one. Yes, the Dell one that I was talking about. But what I'm interested in is DMA available on the dock connector of a laptop that doesn't have a firewire port, that kind of thing. Any others? Yep.
Do I see correctly that the major prerequisite is that you have enough space to insert hardware?
Pretty much, yeah.
From my ThinkPad dock, and I think there is hardly no space. It's very flat, the dock, and you don't have space, so this would be a little bit more problematic.
Yeah, so maybe a recommendation to people who are really paranoid about this kind of thing is make sure that when you decide on which laptop and dock solution to go for one that hasn't any space in there. But, at the end of the day, if you've got a really dedicated attacker who's prepared to fabricate their own really super tiny computers, then there's probably ways of finding space. Any more? Okay, thanks very much.